Hello, welcome back to class. So, we want to continue the discussion on electrolysis. As you can see behind me, the topic is conditions for preferential discharge of a ion. If you are writing WAEC and you are writing JAMB, you need to understand this topic under electrolysis. So, now, in electrolysis, we said that there is a chemical decomposition, alright, when electric current flows through it. Now, this chemical decomposition follows some certain rules and conditions. That is what we want to look at. The rules and the conditions for the discharge of a ion during electrolysis. I will go back to that first example I started with, which is sodium chloride. So if we have sodium chloride, alright, and you dissolve sodium chloride in water, you're going to have sodium ion and chlorine ion. Sodium ion and what? Chlorine ion, right? Of course, water is there. You have water too. So water will decompose to hydrogen ion and hydrogen ion. Now this whole thing is inside the chemical system, like this. Are you getting it now? Of course, we have our electrode, the positive electrode and the negative electrode. Now, what is the condition for preferential discharge? Preferential discharge is that, we have, at this positive time, we have sodium and hydrogen. And we have chlorine and hydrogen ion. Both of these ions, alright, are in the chemical system, alright? That's for the positive and the negative, right? So when you now pass electric current through it, when you pass electric current through this chemical system, what will happen? Are we going to have a total, discharge of everything? No. Now, when you pass electric current through this chemical system, all the positive ion, both sodium and hydrogen ion, will migrate to the negative electrode, right? So this is positive because this is the positive terminal and this is negative. So they will migrate to the what? Negative electrode. This is negative electrode. That's cathode, right? So this is our cathode. Alright? And this one will migrate to the positive electrode. Alright? This is our what? Anode. Please take note. Remember, anions will go to anode. So because they are anions, they go to anode. That's the way to remember your electrode. Alright? While cations will go to what? Cathode. Please, that's a very quick way to remember. Now, as they migrate, you have different ions, sodium ion, hydrogen ion, and you have chlorine ion and hydrogen ion. Which of them will be discharged? If both of them come to this electrode, both of them go to this electrode, that's the sodium and the hydrogen. If sodium and hydrogen go to this electrode here, which of them will be discharged? What does discharge mean? Meaning, at this their current state now, they need electron to be discharged. That is, they need to absorb electron to be discharged, right? Because they've lost electron, that's the meaning of this loss. It has lost one electron. This one also has lost one electron. So they need to regain back that electron so that they will be their normal state, as in their atomic form or molecular form. You understand me? Now, they will come here and receive that electron. So that means that electron will enter into this electrolyte through the cathode. Please take note, for those of you writing down. Electron enter the electrolyte through what? The cathode. So this one will go and receive those electrons, and they will now form the atomic state or their molecular state. Something like this. Sodium will receive electron and become sodium metal. Alright? Then it will now be deposited at the cathode. You understand me? While at the anode, chlorine will receive what? Sorry, chlorine will what? Discharge the excess electron. Chlorine is going to discharge the excess electron and become atom. And of course, that this atomic form of chlorine is not realistic. It has to be a molecule, right? So we'll put 2 here, so that I have 2 here. So 2 moles of electrons discharged. Now, I'm just telling you this is what happens, alright? But my point of discussion is between sodium and hydrogen, which of them is going? Which of them is being discharged? Is it sodium or hydrogen? That is where this topic comes in. We are looking at the conditions for the discharge of ion. Now that you know the meaning of discharge, that is leaving their charge and become their atomic state or molecular form. Now, the conditions are just three. Alright, I'm going to write them there. The first one is what? The position in electrochemical series. So this is the first one there. The position in electrochemical series. Now we have electrochemical series for both metal and non-metal. Alright? We have electrochemical series, and most times students have a kind of acronym or a songs that they form to help them to remember the electrochemical series. Alright? So the electrochemical series, for instance, we have potassium, alright, we have sodium, alright, it goes down to calcium, magnesium, and down like that. Alright, so hydrogen is somewhere here. Alright? Then you now have other metals after hydrogen. Are you getting it now? So you can see the electrochemical series for metal. They also have electrochemical series for non-metal. Right? For non-metal, you have your OH ion, alright, and okay, let me start with the most active. SO4 ion, and you have your NO3 minus, and so on and so forth. Of course, your OH ion is at the bottom. Are you getting it now? So there is an electrochemical series for metals and there is an electrochemical series for non-metals. Are you with me? So for any discharge of a ion to happen here at all in this chemical system, there is a condition that is respected according to the arrangement in the electrochemical series. Are you getting me now? Now, for metals, those ones that are very low in the electrochemical series will be discharged. They will be preferred over those ones that are high. Now, the reason is because of their ionization capability. Alright? Those ones that are at the lower end of this series, they tend to lose their chemical form, or that's their chemical bond easily more than this one. So this one tend to cling to that their bond because they are strong. Of course, you can see that they are high. So in their compound or in their ionic state, they have a more stronger bond. And that stronger bond, to lose it is more difficult than the ones at this bottom. So the ones at the bottom will lose that their electronic structure more than this one. So when they come to discharge of the ions, like in this form now, between sodium and hydrogen, from this explanation I give now, hydrogen is not as strong as sodium, so hydrogen will discharge the ion easily more than sodium. So in this our state, sodium is not going, hydrogen is the one going. So let's rewrite it. Hydrogen is going. So hydrogen ion will be discharged to form what? Hydrogen atom. And of course, hydrogen has to be two, right? It has to be in the molecular form. So two moles of electron will be discharged. You understand that now? Alright? Now, when it comes to negative ions, right, the anions, okay, the ones like we are seeing now, the ones below, alright, obviously. But when it comes to the typical diagram of the electrochemical series, the electrochemical series is in such a way that we have metals go downward like this, then non-metals come upward like this. It's just one single series for both metal and non-metal, right? They are not separated like this for metal and non-metal. No, it's one. So you have the metal go downward like this, and the non-metals come upward this way. Do you understand me now? Alright? So if you follow that series very well, the ones above are the ones here. Alright? These ones, the ones below, you understand me? So this SO4 is totally at the bottom. The SO4 is at the bottom. the SO4 2 minus is at the bottom, followed by the NO3 minus. You get it? So this one is at the top here. The OH is at the top, alright? So this one at the bottom. So now I'm doing this just to explain that when it comes to non-metals, the one above here are preferentially discharged over the ones below in that electrochemical series diagram. Do you understand me now? So you have the hydrogen there, you have something like hydrogen there, you have something like gold and silver. Those ones are far below. Those ones are far below here. Are you getting me now? So in the electrochemical series, for non-metals, the one above are preferentially discharged before the ones below. But for metals, the ones below here, right, are discharged before the ones above. Do you understand? So the position in the electrochemical series matters. Alright, so hydrogen is more like in the middle. Do you understand me now? Now the next condition is the next condition is concentration. Concentration. So the concentration of the ion. If you have a chemical system and one of the species, like out of sodium chloride and water now, one of the species is more concentrated than the other. Alright? It also plays a huge role in which one will be discharged. So if we have more sodium chloride than water, then the concentration will have effect in the discharge. Now, in what way? Now, the concentration will override the position in the electrochemical series if they are close to each other. Are you getting me now? So, in the case of, let's say sodium, are you getting me now? When it comes to sodium and hydrogen is far below and sodium is up there. They are not close to each other because there are many more ions like calcium, alright, magnesium, many more ions. You have lead, alright. There are many more ions before you get to hydrogen. So the concentration is not going to play a role. Take note. The concentration is not going to play any role. Why? Because the distance between sodium and hydrogen, when it comes to this, between sodium and hydrogen now, the distance between sodium and hydrogen is very, very far apart in the electrochemical series. If the distance is close, let's assume we are talking of sodium and calcium or sodium and magnesium. You can see that distance is close, just like a few meters apart or in terms of meter. You can see the distance is close, right? Now, the concentration will play a role. If sodium is more concentrated than calcium, alright, sodium will be discharged. Remember, normally the ones below are supposed to be discharged. Are you getting it? But if they are close together, sodium will not be discharged. The one above will not be discharged if they are close together in that electrochemical series setup. I hope you understand, right? Now, but if they are far apart, the concentration is not going to play any impact in determining the discharge of the ion. That is how concentration affects the preferential discharge. And finally, we have nature of electrode. Now, this nature of electrode is so important. Why is it important? It's because, this is employed in the production of different elements. Your sodium, your calcium and all those elements, it is employed. Alright? Now the nature of electrode since is more important, like I said before. Now if we have a kind of electrode, alright, electrode that have affinity for any of these ions. For instance, in the case of sodium now, if we decide to use mercury, as cathode, listen, if we decide to use mercury as cathode, and the concentration of sodium is more than that of hydrogen, then sodium will be discharged. Why? Because mercury and sodium, they tend to form what we call sodium amalgam. Alright? The marriage between mercury and sodium is very high. So that affinity of sodium to mercury or mercury to sodium will play a huge role when it comes to discharge of the ion. Are you getting it now? I'm going to give you a very, very important scenario concerning what I just said now. That scenario is in the case of having alright, let's say we're having CuSO4, alright, CuSO4 as our electrolyte. And we have copper electrode. Both of them are copper electrodes. Now, when CuSO4 and water ionize, you have Cu2 plus and SO4 2 minus. Then water will give you everything ion and OH minus. If it comes to electrochemical series, the copper is lower than hydrogen, so copper will be discharged as the atom. Copper will be discharged as the atom. There is no problem concerning that. But when it comes to the negative ions like the OH and SO4, instead of any of these to be discharged, this copper ion will go into solution. So what we have is that this copper will be heating up. Because the copper electrode is now dissolving inside the solution, so it will be heating up. It is heating up totally. So it will be dissolving inside the solution to make up for the copper that is leaving the solution. Why? Because of the nature of the electrode. It's a simple explanation. For copper the energy for copper to dissolve is far lower than the energy for any of these to be discharged. So the one that has the lesser energy will have the flow. You understand what I'm saying? So this is just a simple explanation on the conditions that affect the discharge of the ion. So we're going to do more calculation. Just watch out for the calculation under this topic. This is Mr. Brain and this is Putina's tutorial. I expect you to inform your colleagues about the class so that they will subscribe and be part of what we are doing. Share this video to your colleagues. Alright? Bye bye. Thank you.